Exercise 1.1. First question. Use Euclid's algorithm to find HCF of the following questions. Okay. So what is Euclid's algorithm? A is equals to BQ plus R. A and B are the two positive integers and Q is the quotient, R is the remainder. So take first question. Find the HCF of 900 and 270. Select maximum number as A, minimum number 270. Divide by 270. So first do this one in rough work. 900 divided by 270. 273 is a 810. So now the remainder is 90. So now take this 270 as divided by 90. 93 is a 270. Remainder is 0. We have to do this process till get remainder is 0. So now write here 900 is equals to 900 equals to 270 into 3 plus remainder 90. 270 into 3 plus remainder 90. Now write this 270 here is equals to this 90 here. Divide 270 by 90. 93 is a 270. So 90 into 3 270 plus 0. So remainder is 0. We have to stop this process. So now this 90 is called the HCF. So therefore HCF of 900 and 270 is 90. So this is the answer. Now second question. Find the HCF of 196 and 38,220. So first write 38,220 is equals to 196 into 175. So we have to do this one in rough work. 196 into 175, 38,220. Now we get direct remainder 0. So here the remainder is 0. Stop this process. So what is the HCF of this one? HCF of 38,220 and 196 is 175. So 175 is the correct answer. See third question. Find the HCF of 1651 and 2032. So now first of all divide 2032 by 1651. So it's once 1651. Now write the remainder is 381. Now divide this 1651 by 381. So 381 fours 1524. This is 1524. Remainder is 127. Now divide 381 by 127. 127 3 is a 381. Remainder is 0. Now stop this process. So now write the Euclid's division algorithm. A equals to BQ plus R form. A means this is A. So 2032 is equals to 1651 into 1. 1651 into 1 plus remainder 381. Now write this one. 1651 equals to 381 into 381 fours into 4 plus remainder 127. Now we have to write this 381 here. 381 is equals to 127 here. 127 into 3 plus 0. So remainder is 0. Now stop this process. Write the HCF of 1651 and 2032 is 127. Next question. Use Euclid's division algorithm. Show that any positive odd integer is of the form 6q plus 1, 6q plus 3, 6q plus 5. So first write the Euclid's division algorithm. Euclid's division algorithm. So what is Euclid's division algorithm? Let a and b are two positive integer, a equals to b cube plus r, where r is the remainder, 0 less than or equal r less than b. So this is important. First compare with this 6q plus 1. It is bq plus r form. bq plus r. So what is b value? 6. Here also bq plus r form. bq plus r form. So right here let a be a any positive integer. A be any positive integer and b is equals to, what is b value? bq plus r form. So b value is 6. So then r value equals to, r value less than b means less than 6. So therefore what are the possible values of r? R value 0 to 6. R equals to 0, 1, 2, 3, 4, 5. Don't take 6. Why? Because less than 6. So should not take 6. Okay, up to 5 is correct. Now a becomes a equals to bq. What is b value? 6. So 6q plus r. Now put first one, r equals to 0, r value 0, a equals to 6q plus 0 is equals to 6q. 6q can be written as 2 into 3q. So now it is divided by 2. Which number? It is divided by 2. So it is a even positive integer. This is even positive integer. సో మనకి ఈవెన్ నెంబర్ అని ఎట్లా తెలుస్తుంది? 2 టేబుల్తో డివైడ్ చేసి 2 క్యాన్సిల్ అయిపోతే రిమైండర్ 0 వస్తుంది. నౌ పుట్ ఆర్ ఇజ్ ఈక్వల్స్ టు 1. ఇఫ్ ఆర్ ఈక్వల్స్ 1, ఏ ఈక్వల్స్ టు 6q ప్లస్ ఆర్ వాల్యూ 1. నౌ ఇట్ కెన్ బి రిటన్ యాజ్ 2 into 3q plus 1. నౌ కన్సిడర్ 3q యాజ్ m. సపోజ్ 2m plus 1. ఇఫ్ యూ డివైడెడ్ బై 2తో డివైడ్ చేస్తే మనకు రిమైండర్ ఎంత వస్తుంది? రిమైండర్ ఇది 2 టేబుల్తో కట్ అయిపోతుంది. రిమైండర్ ఇక్కడ 0, ఇక్కడ 1 ఉంటుంది. 1 ఉంటుంది కాబట్టి ఇది ఏ నెంబర్ అవుతుంది? ఆడ్ పాజిటివ్ ఇంటీజర్ అవుతుంది. ఆడ్ పాజిటివ్ ఇంటీజర్. సో దిస్ ఈజ్ 6q plus 1. షో దట్ వాట్ ఈస్ క్వశ్చన్? 6q plus 1 ఈజ్ ఏ ఆడ్ ఇంటీజర్. సో ఇది ఆడ్ ఇంటీజర్ అవుతుంది. నౌ పుట్ r equals to 2. r equals to a equals to 6q plus 2. What is common? In both terms 2 is common. It becomes 3q plus 1. Now it is 2 into something. Write as m. Now it is divisible by 2. So it is divisible by 2. That's why it is a even positive integer. So this is even positive integer, not odd positive integer. Okay. So don't take this one. This is even number. So 6q plus 2 is a even number. 6q plus 1 is a odd number. Now put r is equals to 3. If r equals to 3, a equals to 6q plus 3. So it can be written as 6q plus 2 plus 1. 3 can be written as 2 plus 1. From these two terms, what is 6q plus 2 value? Already 2m plus 1. A number is 2m plus 1, then it is a odd number. So it is odd positive integer. So this is correct. Show that 6q plus 3 is a odd positive integer. Odd positive integer అని మనకి ఎట్లా వస్తుంది? ఈవెన్ నెంబర్ అయితే 2m ఫామ్లో ఉండాలి. ఆడ్ నెంబర్ అయితే 2m ప్లస్ 1తో ఫామ్లో ఉండాలి. ఓకేనా? ఓకే. నౌ పుట్ r is equals to 4. Put r equals to 4, then a equals to bq. B value 6q plus 4. What is common here? 2 is common. 3q plus 2. Now it is considered 2 into something. So if a number is 2 into something, then it is a which number? Even number or odd number? Even positive integer. So this is even positive integer. Next, put r is equals to 5. r equals 5, then a equals to 6q plus 5. 6q plus 5 can be written as 4 plus 1. So from first two terms take 2 common, it becomes 3q plus 2 plus 1. consider this number something m, consider this value is m, so 2m plus 1, it is 2m plus 1. If you divide it by 2, it gives remainder 1. If remainder is 1, which number it is? Odd positive integers. So which numbers are in this form? Let's check out once. Question is, show that odd positive integers. Which numbers are odd positive integers? First one is 6 cube plus 1 is odd number, and second one 6 cube plus 3. So 6 cube plus 1, 6 cube plus 3, and last one 6 cube plus 5. This is 6 cube plus 5 is also odd number. So which numbers are odd numbers now? First one is 6 cube plus 1, 6 cube plus 3, 6 cube plus 5. All are odd positive integers. Odd positive integers. So this is the answer. Now see question number 3. Use Euclid's division algorithm. The square of any positive integer of the form 3p or 3p plus 1. Any positive square number always in this form. So first write Euclid's division algorithm. Euclid's division algorithm. What is Euclid's division algorithm? A and B are two positive integers. A equals to bq plus r, where r is the remainder which is always less than b. Now compare with this one, bq plus r1. So right here, let a be any positive integer. Let a be any positive integer. And what is b value? Tell me what is b value? bq plus r form. So b is equals to 3. If b is 3, what is r value? 0 less than r equal r less than 3. Therefore, what are the possible values of r? R value 0 to 3, but less than 3. 0, 1, 2. Now put r is equals to 0. Then what is a value? A is equals to bq plus r. B value 3. 3q plus r. Now put r value 0. 3q plus 0. A is equals to 3q. Now do the square of this number. So what is a square? A square equals to 3q square. 3q square, 9q square. It can be written as 3 into 3q square. 3 into, now consider this 3q square as p. Consider this 3q square as p. So now what is the question? Square of any number must be in the form of 3p. See, square of this number is 3p. So this is proved. Now put second one. Put r is equals to 1. Then a is equals to 3q plus 1. Now do its square. So a square equals to 3q plus 1 whole square. So this is a plus b whole square. What is a plus b whole square? A square plus b square plus 2ab, 6q. Okay, now rearrange the terms. So a square equals to 9q square plus 6q plus 1. So from two terms, what is common? 3 is common. If you take 3 common, it becomes 3q square plus 2q plus 1. Now consider this one as p. It becomes 3p plus 1. So we have to prove square of any positive number is in the form 3p plus 1. 3p plus 1 వచ్చేసిందా ఇట్లా. Put last one. Put r equals to 2. If r equals to 2, a equals to bq means 3q plus 2. Now square this one. A square equals to 3q plus 2 whole square. So a plus b whole square, a square plus 2ab, 2 3 is 6, 6 2 is 12q plus b square 4. Okay. Now write this one, 9q square 12q plus, ఆల్వేస్ మనం ఏం చేయాలంటే 3 ఇంటూ సంథింగ్ వచ్చేటట్టు రాయాలి. 3 ఇంటూ సంథింగ్ రావాలంటే ఈ 4ని మనం స్ప్లిట్ చేయాలి. 4ని ఎట్లా స్ప్లిట్ చేయాలి? 3 ప్లస్ 1గా స్ప్లిట్ చేయాలి. సో ఫ్రమ్ ఫస్ట్ 3 టర్మ్స్ వాట్ ఈస్ కామన్? 3 ఈజ్ కామన్. 3 కామన్, 3q స్క్వేర్ ప్లస్ 4q ప్లస్ 1 plus 1. Now treat this as p, this one as p, 3p plus 1. So finally we proved square of any number must be in either 3p or 3p plus 1. So okay, hence proved. Next question, use division algorithm, show that cube of any positive integer of the form. So use same method and solve this. Let a be any positive integer and b is equals to 3. 0 less than or less than b, that means 0 less than or equals to or less than 3. So Euclid's division algorithm, a equals to b cube plus r, that means a equals to 3q plus r. Now put r is equals to 0, then a equals to 3q plus 0 equals to 3q. Now take its cube. A cube is equals to 3q whole cube. So this is 27 cube. 27 cube means right 9 into 9 in the cross 9m, 9 into something from the 9 into 3 cube equals to 9 into, consider this is m, so 9m. So cube of any number is 9m. Next put r is equals to 1, then a equals to 3 cube plus 1. Cube of this number a cube equals to 3 cube plus 1 whole cube. So it is a plus b whole cube. So expand a plus b whole cube. A cube plus 2a square b plus 3a square b plus 3a b square means it becomes 9 cube plus 1. So now take 3 common from first 3 terms. 9 cube plus 9q square plus cube plus 1. Okay, take 9 common, 9. Okay, here take 9 common, not 3. Take 9 common. Okay, why? Because it is in the form of 9. 9 3 cube plus 3q square cube plus 1. Now it becomes 9 into m plus 1 form. Okay, next put r equals to 2, then a becomes a equals to 3q plus 2. Now take its cube. A cube equals to 3q plus 2 whole cube is equals to 27q cube plus 54q square plus 36q plus 8. Okay, now take 9 common. 9 of 3 cube plus 6q square plus 4q plus 8. Consider this as m. So now 9m plus 8. So cube of, therefore cube of any positive integer is of the form always 9m, 9m plus 1 and 9m plus 8. Okay, సో అక్కడ మనకు 3 ఉంటే 3 కామన్ తీయాలి, ఇక్కడ 9 ఉంటే 9 కామన్ తీయాలి. Last one, show that one and only one out of these numbers is divisible by 3 where n is any positive integer. So write here first, let n be any positive integer divisible by 3, so take b equals to 3. Therefore r value 0 less than or less than b. Therefore what are the possible values of r less than 3? So r is equals to 0, 1, 2. Therefore Euclid's division algorithm, Euclid's division algorithm, a equals, a means here n equals to bq plus r, that means 3q plus r. So first put r equals to 0, r equals 0, n equals to 3q plus 0 is equals to 3q. Show that is it divisible by 3? Yes, 3 into q, therefore it is divisible by 3. It is divisible by 3. Now put r equals to 1, n equals to 3q plus 1, n equals to 3q plus 1. Okay, don't take one of this number, so take n plus 2 number. This is n equals to 3q plus 1. Now put n value 2, n plus 2, r is equals to 0. Okay, use r value 0. Now take n plus 2 value, n plus 2. n plus 2 means n value 3q, already 3q plus 2. So it is not divisible by 3. Okay, this is not divisible by 3. Now take n plus 4. n plus 4 means 3q plus 4. This can be written as 3q plus 3 plus 1. From first two terms 3 is common, q plus 1 plus 1. So it is also not divisible by 3. Okay, so one of the three numbers is divisible by 3. n divisible by 3, n plus 2 not divisible by 3, n plus 4 not divisible by 3. In this way we have to check r equals to 1 and r equals to 2 also. Put r is equals to 1 and check n value, n plus 2, n plus 4 value. r equals to 1, n equals to 3q plus 1. 3q plus 1 is not divisible by 3. Now take n plus 2. n plus 2 value 3, n value 3q plus 1 plus 2. It becomes 3q plus 3. 3 common. 3 of q plus 1. Yes, it is divisible by 3. Now take n plus 4. 3q plus 1 plus 4. 3q plus 5. 5 can be written as 3 plus 2. From first two terms 3 is common. Q plus 1, 2. It is also not divisible by 3. So we proved among n, n plus 2, n plus 4 only one number is divisible by 3. In this way we have to check r equals to put r equals to 2, then n is equals to 3q plus 2. Yes, it is not divided by 3. Okay, next n plus 2. When r equals to, check n plus 2, n value 3q plus 2 plus 2, 3q plus 4, it can be written as 3q plus 3 plus 1. Now first three terms 3 common, q plus 1 plus 1. So it is not divided by 3. Okay, not divided by 3. Now write n plus 4. n value 3q plus 2 plus 4 is equals to 3q plus 6. What is common? 3 common, q plus 2. Yes, it is divided by 3. Okay, so now when r equals to r2 aithe n value not divisible by 3, n plus 2 not divisible by 3, n plus 4 divisible by 3. So therefore n plus 2, n plus 4, only one is divisible by 3. Okay, thank you for watching.